Hello everyone, my name is Duy, and today I will give you a design project for assignment 2, which is instructed by Professor W and Professor Maria Gonzalez. I have divided my presentation into 4 main parts. Firstly, I will introduce about this assignment, how to use Prosper. Secondly, I will show how to input data in the software, and after that the result will be shown and calculated. Finally, I will give you some conclusion and evaluation about this assignment. Now, let's turn to first session. So in here, you know that web modeling in artificial leaf designs are regarded among the core tools in production engineering, especially for the web performance and production optimization. And Prosper is a web performance design and optimization program that is part of Integrated Production Modeling Toolkit (IPM). And Prosper also is designed to allow the building of reliable and consistent web models with the ability to address this aspect of web-borne modeling, for example, like PVT, VLP, IPR, and this tool is the industry standard for web modeling worldwide. And also in this assignment, I will use the Prosper to set up a basic web model, which it requires a flood characterization, IBR and skin modeling, VLP construction, and matching them. And finally, the artificial leaf design and optimization. So here, at the beginning, I will create the IPR and the IPR curves. Supposing in this square the flux is oil and water, and I apply the gas slip method in this curve. After that, we need to input some parameters such as GOR, gas oil ratio, is equal to 800. The oil gravity here is 37.5, and the gas gravity is equal to 0.856. And here we choose the water salinity is equal to 0. Then we'll click match there and calculate until the PVT matches. So when the PVT matches, after clicking the regression button, the calculated table is shown. And here you can see that they show the change in different standard deviation with 2 types of parameters here. Then I want to recheck with the automatic calculation. In this figure, you can see that the temperature and the pressures is increased with the number of steps is 5. So here the temperature is increased from 27 to 91, and the pressure from 185 to 2,290. So here is the calculation result with different temperature and pressure we have in different each parameter. So here we have the temperature, pressure, bubble point, gas ratio, oil density, oil gravity, and you can see that the bubble point here so have 4 main values. So the first one is 2016. The second one is 2,145.05. The third one is 2,247.24, and the last one 332.27. So in lookup table and in table 1, there is 5 pressure. There is 5 pressure here with different parameters. But in here we have the same in temperature is equal to 27. Purple point is equal to 216.7.01. Next, I choose the reservoir methods is PI entry with the reservoir pressure is equal to 2,290, and the temperature here is 91 degrees. Water cut is 59.12 and the total gas oil ratio is 800. After the air is inputted, the IPR curve is generated. Here we have the absolute of flood E equal to 863.4 cubic tank. Then I want to make a survey with rate model is automatic linear with the same value in water cut and total of gas ratio gravity GOR gas or ratio. So here we have the same value in water cut and total gas ratio. In reservoir pressure, we input the range of pressure from 1000 to 5000 psi3 here. At the finish, we have the figure show the change in IPR with different pressure here. So we have 5 lines. The green line here show the IPR curve change in different pressure. Then I choose the calculation with top new pressures is equal to 2000 psi3 with the same with the water cut, the total gas oil ratio, but the method here is different. With the surface is spread in groups and in vertical lift is petroleum is 2. Different with the first one, which the pressure now is from 2000 to 5000 with 3016 as 3600 now is bubble point in pressure. And here we can see that the green line is the IPR with the different pressure and the red one is the VLP curve. In here, the VLP cut 3 lines of IPR. Thus, it means that in this place, we can produce oil. And if you want to produce more and more oil, so I think that you should make the pressure increase so that the VLP can cut all of them. And it makes the well can produce more oil, but you want to think about the environment and how to preserve this one. So now let's move on the well design. At first, I want to check the equipment data. I choose on input data with deviation survey equipment, downhole equipment, geothermal gradient, and average heat capacities. And here it can be seen that the figure show the change in depth with the change in the true vertical depth about the deviation survey first. So you have 4 columns with the measured depth, it changing, the true vertical depth, the cumulative displacement, and the angle for each measurement. Each depth, with all of them is different. Also at the survey equipment tab, we set up the choke with the pipe inside diameter is equal to 2 inch and the rate multiplier is equal to 1. Next, I want to set 3 topping with different in depth and change in topping inside diameter. But here the topping inside roundness is the same. It's equal to 0.001 inch. And you have 3 topping here. With the first one is equal to 2,781.7 and the change in DR. Then I want to check the geothermal gradient. And here I choose the overall heat transfer coefficient is equal to 8. And you can see it, formation measure depth and formation temperature is changing. It tends to be in green. Furthermore, the specific heat of oil now is equal to 0.53 and the gas the specific of gas now is 0.51, and normally the water specific heat is equal to 1. After all, we have the equipment summary, and in this slide show my gas lift design has one choke, one Christmas tree, and some topping with the different in depth. So here you have 18 parameter, 18 types, with the number 2 is your choke, number 3 Christmas tree, and 14 topping with the change. So here it shows all input parameter in realistic with the topping, Christmas tree, and also with the valve in this design. So here you can see that at the true vertical depth is equal to 2,866 feet. You have the different in inch, and the inch is the same, but in the true vertical depth is equal to 2,995. So you have 6 inch in parameter. Then I want to input the gas lift gravity is equal to 0.856 with gas liquid ratio. Injected is equal to 250, and the gas lift method here it fixes depth of injection. Then we choose calculated from the mass production in design rate method, with the maximum liquid rate is now is equal to 707 STB per day. Again, then we show the table about the calculated rate with 2 types of parameter is calculated rate and objective gradient. Here in my gas lift design, and here there are 2 valves in depth. In the depth nearly 1,700 and 2,000 and 200 and 2,100. And here you have the blue line here is about the pressure. The pressure tends to be increased also with the temperature, and it's increased slightly, a little bit fluctuation. The red line one, so you have the operating gas gradient. So the vertical one, yeah, it tends to be nearly vertical, and the angle here is nearly 15 to 20 degree here. And also you have the unloading gradient, the line unloading the unloading gradient 2 point. And you have 2 of them in the valve 1 and the other in the valve 2. Also, the pink line is show the minimum pressure. So you can see that the minimum pressure is lower than the pressure we made in this survey. And also, so you have the reservoir at the same with 2,230 with I3. With the pressure the same is 91. So in this assignment, I have shown how to use Prosper and how to calculate the IPR and the VRB curve with different pressure and skin factor. As can be seen from the previous slide, when the skin factor increases, the flow rate declines slightly. Furthermore, I have already designed a simple well by using gas lift method, and also show the pressure will be increased when the temperature also go up, when the depth tend to be higher. All in all, Prosper is a useful software for engineering to solve some problem in this major and support engineer well. Thank you for listening.